This video will talk about similar triangles and the angle-angle theorem. These two figures are similar, which means that they are the same shape but not the same size. In similar figures, corresponding angles are congruent and corresponding sides are proportional. If I move the figures around and change their orientation, are they still similar? They are. What about if I dilate them and make them grow or shrink? They are still similar. In fact, if you can map one figure to another through any series of transformations, they are similar. Reflection, translation, rotation, and dilation all keep a transformed image similar to the original. Let's try some problems. The triangles below are similar. The measures of two angles in each triangle are labeled, and x does not equal y. Is angle C congruent to angle F? Start with what you know. Since the triangles are similar, corresponding angles are congruent. And what do you know about the sum of the angles in a triangle? The sum of the angles in a triangle are equal to 180 degrees. The measure of angle C is equal to 180 minus the sum of the measures of x plus y. What about the measure of angle F? That is also equal to 180 minus the sum of the measures of x and y. Since they are both equal to the same thing, it means that the angles are equal or congruent to each other. So the answer to this question is yes, angle C is congruent to angle F. Based on this problem, what can you say about two triangles who have two congruent corresponding angles? The angle-angle theorem tells us that if two angles of one triangle are congruent to two corresponding angles of another triangle, then the triangles must be similar. Try this problem. The triangles below are similar. The measure of three angles in each triangle are labeled, and both triangles are scalene. Find the values of x, y, and z. To solve this problem, you need to combine the information from the two triangles to find the missing measure. The triangles are similar, so corresponding angles are congruent. That means that angle M is congruent to angle P, which is 83 degrees. So y is 83 degrees. Similarly, angle N is congruent to angle Q, so Z is 42 degrees. Since x is the only missing angle in the triangle, you can find it by subtracting the sum of the other two angles from 180. So x is equal to 55 degrees. And now you have all three angle measures. Okay, let's try one last problem. Prove the triangles below are similar by showing that you can map one to the other through a series of transformations. Looking at the two triangles, they look similar, but if you don't have any angle measurements, you can't use the angle-angle theorem. Instead, you have to use the fact that if two triangles are similar, then you can map one to the other through a series of transformations. So do you think you can transform triangle XYZ in such a way that it would overlap triangle PQR? First, try translating it. So that point Z lines up with point R. A translation is a slide in the vertical or horizontal direction. Call the translated image triangle X', Y', Z'. Now dilate the triangle so that it is the same size as triangle PQR. Call the new dilated image triangle X', Y', Z'. The last step is to reflect the triangle over a line that goes through point Z', to see if it overlays triangle PQR. After a reflection, it does lie exactly on top of triangle PQR. Since triangle XYZ can be mapped to triangle PQR through a series of transformations, the triangles are similar. So in review, similar figures have corresponding angles that are congruent and proportional sides. Similar figures can be mapped from one to the other through a series of transformations, and triangles can be proved similar through the angle-angle theorem. Best of luck!